So here's another example. We want to find all the critical numbers of the function g of x in this example and determine the location of any absolute or relative extrema if we can possibly do so. All right, well, that's what we're going to do right here is we're going to find our critical numbers. So we're going to find our critical numbers by taking the derivative of g of x. Now this is a little bit more tricky because we've got that fractional exponent, so we're going to have to figure out what's going to happen there. But let's take a look. G of x, g prime of x, if we take its derivative, is going to be 3 times the derivative of x to the 2/3, so that's 2/3, times x to the 2/3 minus 1, that's negative 1/3, minus 2. So working that out, of course, that becomes 1 over x to the 1/3 minus 2. All right, so g prime of x is 1 over x to the 1/3 minus 2. Critical numbers are any points on an interval at which we either have a value that's undefined or a value where the function's derivative is equal to 0. We might actually have a possibility of both on this, so let's check it out. First of all, we could say that g prime is undefined at x equals 0. Now, why would that be? Well, if you look at g prime of x right here, we can see that substituting in 0 for x at this point produces a point that's outside of the domain of the derivative, and at 0 we're going to get 1 over 0. That's undefined. Right? So it's undefined at x equals 0. So that's a critical number for us, and that is certainly interior to our interval. Are there any points where g prime is equal to 0? Well, we're going to do that by setting 1 over x cubed, x to the 1/3 power, pardon me, minus 2 equal to 0. Moving the 2 over, 1 over x to the 1/3 equals 2. We would multiply both sides by x to the 1/3 and find that x is equal to 1 is equal to 2 times x to the 1/3 power, which is to say 1/2 equals x to the 1/3 power. And since we're raising it to a fractional exponent, we can get rid of that fraction by cubing both sides. So 1/2 to the 3rd power is equal to x to the 1/3 power cubed. In other words, x is equal to 1/8. There is another point on this interval where the function has a critical number. So that's at x equals 1/8. So now we've got 2 critical numbers. Now, of course, we should also look at this function. G of x is defined everywhere on this interval. Right? Even if we substitute in 0, that is a point where this function is undefined. So the points where we're going to have to look for our critical numbers right here, there's a few of them. And so we're just going to have to do a little bit of the work right here. We've got -1 as one of the endpoints, right? We want to find f of -1 and f of 1. We've got 0 as one of our critical numbers, as well as 1/8 as one of our critical numbers, and finally +1. So there's 4 places that we should be looking for those critical numbers. All right, so how are we going to do it? Well, let's compare. What is g of -1? Well, g of -1 means that we're going to take 3 times -1 and raise it to the 2/3 power, and subtract 2 times -1. That's going to give us 3 times, well, -1 to the 2/3, that's -1 squared, which is a +1, and we take its cube root. That's +1. So that's 3 plus 2, which means we get 5 right here. So the value of g of x at this point is equal to 5. All right, let's take a look at g of 0. Well, that's actually not a bad one to figure out, because 0 to the 2/3 would still be 0. And 2 times 0, also 0. Therefore, overall, g of 0 is equal to 0. A little bit more work trying to find g of 1/8. So that's going to be 3 times 1/8 to the 2/3 power. And we're going to subtract from that 2 times the fraction 1/8. Well, doing a little bit of the work right here, 1/8 to the 2/3 means that we could take the cube root of 1/8, which is 1/2, and then square that. So we're going to have 3 times 1/4 minus 2 times 1/8. Well, that actually ends up being 1/4. So we've got 3/4 minus 1/4, and that comes out to be 2/4. That's 1/2. That's 1/2. So we get 1/2 at x equals 1/8. All right. One more point that we have to work out, g of 1. Let's find out what happens there. If we put in 1, we're going to get 3 times 1 to the 2/3 power minus 2 times 1. Well, that ends up being 3, 1 to the 2/3, 1 to any power other than 0 is equal to, well, even to 0. That's equal to 1. Minus 2, we end up with 1 right here. So what should we make of this? Well, at -1, we have the highest value that this function ever achieves. That means that we have our absolute maximum at x equals -1. 0 looks to be the smallest value that this function achieves, so at x equals 0, we've got our absolute minimum. At x equals 1/8, we tend to go up right here, which is a 1/2. This is sort of funny right here. We get 1/2. That is a point at which we have a value, and then we have x equals 1. Kind of weird right here. Did we miss something? Let's see. 3 times 2/3, that's 1/4, right? Minus 2 times 1/8. Well, we've got 1/8. What did I miss right here? Did I miss something? Well, one thing that we could conclude then is that at this point, this is actually going to be the kind of point where we do come to a 0 derivative, but the value continues to increase. In that case, we have got neither a relative max or a minimum, right? We go 0 to 1/2 to 1. And at x equals 1, we get 1, but that's not the highest value. So both of these points are neither maximums nor minimums. From the perspective of the function, we can simply ignore them. Kind of weird.